Hi everyone, today I'm gonna give you a quick demo about how to deploy a containerized application to Kubernetes. My name is Louis Somel, Senior DevOps Advisor at Solution Experta. So thank you joining me on that demo. So let's start. So where can you host a containers? You can host container on operating system that have container support. On Windows, these options are the Windows 10 Anniversary Edition or newer, only with Hyper-V isolation mode, so you need to activate it. And on Windows Server 2016. You also can simply run container on the operating systems. For real-world application, you likely also want additional capabilities such as automation, automatic recovery after application crash, fault tolerance, zero downtime deployments, resource management across machine options to run container composition. Instead of building these capabilities yourself, you can also use containers cluster that are specifically built to support these capabilities. At present, there are 4 mainstream cluster technology that you can use to run in highly scalable fashion. These are Docker Swarm, Docker DCOS, Kubernetes, Azure Service Fabric, and Azure App Services. By the time I wrote those slides, other technology also are available to make such things. But these are the main one that we're gonna see today. So, what is the prerequisite before going to Kubernetes? First, you need the container registry. Container registry are used to store your container image you build. And then when times come to deploy it on Kubernetes, you will deploy a manifest that will pull out your container image in order to start it as a container instance inside the orchestrator you choose. Personally, I'm using more a Docker Hub to store public container image that are made sometime more generic. The GitHub package also provide a capability to store your container image, and you can choose to have public repository, private repository for your container images. And at the last one, you have the Azure Container Registry that is available on Azure. So this is basically the kind of container registry I'm using. There are more. You will easily find some other like Nexus or JFrog have those capability tools. The second prerequisite is to have an accessible cluster, Kubernetes cluster. When we say about accessible Kubernetes cluster, it's you have to make, if you have a private container registry, you have to make it available from your Kubernetes cluster and so on. So So in that demo, we're going to use AKS, but AKS stands for Azure Kubernetes Services. AKS is the Kubernetes distribution available via Amazon, and GKS is the one that is provided by Google. To be honest, in that demo, it will be transparent because we don't speak much about AKS, EKS, GKS. We simply use the AKS cluster I have, but we don't dig up in that path. And last thing, but not the least, you need kubectl and Elm command line tools installed on your machine. The first one, kubectl, will help you to interact with your Kubernetes cluster, and Elm will help you to package your Kubernetes manifest as a single package like we have with NPM for Node.js. And or NuGet packages, but it's Elm package. Elm is we're gonna see a bit later. So what we're gonna, how we're gonna deploy our Kubernetes, our container images on Kubernetes? We have both different way. The first, but the most basic one is to write down a standard Kubernetes manifest artifacts. So the manifest is a specification of Kubernetes API object in JSON or YAML format. A manifest specifies the desired state of an object that Kubernetes will maintain when you apply the manifest. We could define the desired state of our application through a set of keys value pair called manifest, which further deploy it into the Kubernetes cluster to properly maintain it. So we're gonna see it later. And this is a sample of the standard Kubernetes manifest files. The screenshot doesn't give much value, but we're gonna see it in VS Code as well. And what is Helm chart for Kubernetes? In fact, Helm is a package manager for Kubernetes, similar to Yum for Linux or NPM for Node.js. Chart deployed by Helm are complete package Kubernetes application. What we stand for that, what it means for that, it's when you write down a Helm chart is because you group together every piece of your software you want to deploy in Kubernetes. So you can have multiple container image that you want to package there in it. They include versionize pre-configured application resources that can be deployed as a single unit, exactly what we speak about. You can deploy different versions of the chart with different set of configuration. What it stands for. In fact, your Helm package will be environment agnostic, so you're normally not gonna hard code value for dev or prod inside the Helm chart. You simply when you run the Helm chart deployment, you simply inject which value file you want to apply, and then the Helm chart will simply took those value and you apply the right configuration set you need for your deployment. Helm is an important part of a well-designed Kubernetes architecture. It can significantly improve the Kubernetes deployment experience by improving productivity, making Kubernetes application less complex, and making it easier to manage cloud-native and microservice applications. Yeah, again, this screenshot, really sorry for that. It's not really precise. In fact, in the screen capture, it's quite small, but we're gonna see it later on. So let's start with that. We're gonna deploy a simple Hello World website on a Kubernetes cluster that is empty. So let's go there. Oops. Okay. What I have here, I have a chart. I will close everything because my stuff is not really, it's kind of messy right now. Let's start Docker. Okay, previously we created an application that was a simple website, a simple Hello World website, really dummy one. What we have now is we want to deploy it in Kubernetes. So to make it happen in Kubernetes, we need to define a manifest. So we have that manifest over here. So we're gonna in Kubernetes to instantiate a resilient application available. We need to define a deployment artifact. So it's why we have deployment set as kind for the deployment.yaml file. In it, we have the name of our deployment would be mydemo 2201-app. We're gonna have 10 replica. Maybe it's too much for now. Okay. We're gonna stick to 2 replica. What it means is the deployment will always create a replica set. That replica set will ensure that we have always the number of replica we put in the deployment file. So if my application crash in production on my Kubernetes cluster, the replica set will be responsible to keep it at 2, always 2 active container instances. So it's what's it gonna do, and the replica set will create pod. Of course, I can simply create a pod as a deployment artifact, but it will not be resilient. So the way to work with Kubernetes to deploy an application is to create a deployment, or let's say, okay, I will start. There's other kind of deployment we can do. Now we have the deployment, but we can have a stateful set and daemons. But this is it's subject to another demonstration. So we have our deployment, and inside the deployment, we have the spec, the number of replica, and then the template. The template will give we're gonna configure and give the specification about what container we want to run. So we see that container took a S. That means we can have multiple container flavor in part of our deployment, but it's not the case now. We keep it simple as possible for the demo. So we're gonna create a pod, mydemo 2100-app. I could call it something else but I tend to be stick to the deployment simply for simplicity. But it is, and now the image. How I can link my Kubernetes, my application deployment from Kubernetes to tell Kubernetes took that container image version. So it's that property here, images, is the one that we need to set. So what we have domain / my hello world _ the version number. This will pull the container image with that from that repository where it is. By default, it's point out to Docker Hub. You can have a link to your private repo for that, your private container images repo. But for now, for that demo, we stick to Docker Hub. So I'm gonna go on Docker Hub, on my subscription of Docker Hub. Let me just find the page. Okay. We see now that on my account on Docker, my repository also, because I have one repository on Docker Hub. It's a public one. I don't have my Hello World application. Okay. My Hello World is not there. So if I apply it to Kubernetes, it will not work because the image doesn't exist. So So first thing first, I need to push my image to Docker Hub. So I have my Docker file here for my application. So I'm gonna push it there. So docker build -t l tournel my hello world 0.0.1. But there's something different, kind of sexy here, because I'm running on Mac. My Kubernetes cluster doesn't run on a Mac, and it doesn't run on the Apple Silicon processor, which is an ARM processor. And if I compile it as without specifying the platform where my container is targeted to be deployed, it won't work because the CPU architecture is quite different. So I need to mention platform Linux AMD 64 dot. Let me just no, okay, not equal shit. Fun. So let's build it. So I'm building it now on my machine. Okay, I'm almost done. So now it's building in with my machine as a container image targeted for Linux / AMD 64. Why Linux? Because we can have Docker container run for PC, for Windows, and we have Linux container also. So we target container image based on a Linux host. So it's why it's Linux / AMD 64. Gonna wait a little bit to build that images, and I took the intention to not say I'm building a Docker. I'm not building a Docker. I'm building a container. Docker is a product. Container is the artifact, and is the proper terminology to use when times comes to deploy a container. It's a container image. It's not a Docker images. Okay, it's done. Let's do Docker images. Whoops. Docker image. And what I have my container image for the repository /my hello world. I'm gonna push it on Docker Hub. Docker push console my hello world. So before going there, we're gonna look at it over here. I don't have anything related to my hello world. So I have Azure Cube Helm Runner with 776 download, and PowerShell Core as CLI 362 download. Those are containers that I'm using for other stuff. So the one we're gonna build is the my hello world. So let's do Docker push. If I'm running on with Podman instead of Docker for this step, so the command will be podman space push the name of the images. Took some time because the container images took 217 megabytes. Yeah. Thank you, VS Code, for the warning. Thank you. And sorry for the noise there. The truck that load the snow outside. Okay, impressive. It's almost push. It's almost push. We're gonna see it there in a few seconds. Not yet. Okay, now it's push. So what we have now? We have the container image that we've been on locally. Normally you don't push container image that you build on your machine to the Kubernetes cluster. Normally you do that with the CI/CD pipeline. But it's a demo, so things are quite more easier. So what we have there? We have only one version. Later we're gonna push version 2. Version 0.02. So yeah, so let's get back. Okay, so now probably I can push the deployment in Kubernetes, but I will explain a little bit more about what are those values. The ports here expose the port that you want to be accessible inside the Kubernetes network of your namespace for the application. It's not exposed to the external world like the public internet. So it responds on port 80. And to make the container instance accessible, we need to deploy the services. The services will be responsible to load balance the traffic between the number of container image you have of your application in Kubernetes. So if you have two instances of your application, you will simply reach the service, and the service will route the traffic to the active one. If you have 10 container instance active, it will load it. It will route the traffic to one of the 10. If you have 10 container instance and one is down, so the service will simply route the traffic to the 9 container image you have that are available. So again, the service, the kind of the artifact is the services, have the service name I defined. The type here is load balance, which is the load balance, service type load balancer. So we're gonna have an internal IP address inside Kubernetes for that service, and also an external IP address. So every traffic that came from the external will reach directly the services. At contrary, we normally do cluster IP services, and then we map an ingress to route the traffic to the proper service, because the ingress will give us the ability to put a certificate for our application, because we don't store the certificate inside the container itself. We keep it clean, so we keep it out of the container. It's work like a load balancer. and in the reverse proxy. So and we have other capability with ingress to, by example, filter the traffic, the geo IP traffic. We have cool capability to also apply security filtering from the kind of the request we have, and so on. So it's a big subject. It can be really complex, but we don't go there for that. For the first thing we're gonna do now, I'm gonna go inside the stuff. So I'm gonna deploy the service and the deployment inside his own namespace in Kubernetes, because I want to isolate my deployment inside his own namespace, and the namespace have some security point that we cannot interact with other namespace. So I will create the namespace demo 21A. Then, the namespace already exists. Okay, cool. Get services. Clear kubectl. Apply. I'm gonna apply my file called name service.yaml in the namespace demo A. So the service is created, but I will do a kubectl get services demo A, and I see that my demo services, the name has been created, the type load balancer, the cluster IP, this is the internal IP address for that services, and I don't have yet an external IP, and the service is reachable from the external on the port 80. So let's see if I have an IP. Now I have an IP. So with that IP, I will reach these services. So if I go here, oops, nothing will respond for sure, because I did not deploy the application yet. So let's deploy the application. kubectl again, apply -f deployment.yaml and demo 2001A. Now it's created. I'm gonna simply look at get deployment demo. I'm gonna list the deployment inside the demo 201A. And what I have, but my deployment has been created. I have 2 pod ready on 2 needed. So everything is aligned, everything is working. So if I go back on my IP address, now my website is up. My hello world is up. Everything is okay. Let's look at the kubectl get pod demo. I have 2 pod running. I'm gonna look at the log, kubectl logs 2008. So now kubectl log, the name of the container -n. It's to get the output of the logs generated by the application, as we do normally on our local machine when we do the development. So that's it. Now we have an application that is running on Kubernetes. Let's do one other crazy thing is I have only 2 replica. I'm gonna put 10 replica, okay? And see here in kubectl get pod name demo 2001. I only have two. So I'm gonna simply apply the deployment. I'm applying the exact same chart, not chart, sorry, deployment file, but with 10 replica instead of 2. So hit enter, it's apply. I'm gonna list the pod now, and what I have. The deployment create the add 8 pod, because I had 2, so I need 10, so it add 8. And now I see that the 10 is running. So it's that simple, and the application is still there. Okay. So let's do that. Clear. Okay. So let's have a look now at the Helm chart. Okay. The Helm chart is a package manager. With every package manager, we have basic command. I will not expose those commands here. I will give you the link at the end of the demonstration. But the chart, yeah. So for our demo, what we did is we create a chart with the name of my application is my app. Application version of the chart, application version. Okay. I have a value file over here. I don't have a specific and dev or production difference. What I want to expose here is I have a value file where I can centralize all my dynamic configuration that could change between each environment. So for that value files here, I want 4 replica. If I have 10, I will put 10 there, but I will simply change one file instead of changing multiple Kubernetes artifacts like the services and the deployment or the config map also. So everything I need to do is to change it there. I have the image configuration, the repository, the total IC, and so on. So I will. The service, load balancer, port 80. Ingress I don't have. Auto scaling, I'm not activating it yet. It's another fault. So we stick to simple things. So let's see the deployment, because we can compare Apple with Apple. So before we have some. The main advantage we have with Helm is we can tokenize our Kubernetes artifact. We can. Who is that? Okay, sorry, someone was outside. We can apply some code logic to play around with variables inside the files and make the Kubernetes artifact more fine-grained with the condition we want. So we make it conditional, by example. So you see that in the spec here, I have what? I have if not value to scale enable. So put the value, put the replicate count from the value file. If not, so replicas over here is not defined. It will be the auto scaling that will be, but it's not set in the stone. Those stuff you can do whatever you want by the condition you made it. As you can see, the container name, I take the chart name defined in my chart here. So the container name will have my app instead of have my hello world or demo, stuff like that. Or potato. For the services, same things. Value service port. So I define here service port. We have the port 80. We can change it to 8080. We're gonna do that too. So it's a little bit more complex with Helm when we start playing around with Kubernetes. So it's why I recommend to use the Kubernetes artifact to have an idea about the terminology, how it works, playing around with that. But once you want to tokenize and variabilize your deployment with your container image to Kubernetes, you have to use Helm. It's really the way to go. There's another tools, I don't know, but I don't remember which tool it is, but it exists another tools like Helm to make those kind of things. It's one on another, but don't stick to standard Kubernetes manifest file with replacement token in your pipeline. It will become a mess over time. So let's deploy it. So I'm gonna, because I cheat a little bit, we're gonna simply run the command helm upgrade. Why upgrade? It's a tweak because normally you can use helm install, but if it exists, you will not, the Helm install will fail because the application is already existing. If you use Helm upgrade with the option -- install, it will, if it's not exist, it will create it. So I'm gonna upgrade the chart demo 2001. If it not exists, it will create it. This will give me the capability to roll back over time. We can roll back version of our Helm chart deployed in Kubernetes. What it means, by example, if I have an application that have 5, 6, or maybe 1 container image with some value in it that won't works, or it's flaky, or it's bogus, and I want to go back, I can simply run Helm rollback the revision of the deployment made for that, and then instantly the application will be rolled back completely, instead of having to control it manually with Kubernetes artifact. So and in this demo we don't wrap as a zip file we don't create the official package that we can push in the Helm package management system. We simply refer to the folder where it actually is. It's inside my app. I install it under the demo Helm namespace, and if the namespace doesn't exist, I create a namespace. So that's it. Let's install it. So now the release demo not exists, so it currently installed the Helm chart. So we're gonna have a look at our stuff. kubectl get but in the demo Helm. Okay, it's pending now. Let's see the services, because the services all namespaces. So we still don't have an IP address for the demo Helm. Let's wait. Oh, we have one. So this IP over here is the IP address used for the deployment of the My Hello World container images via Helm packages on my Kubernetes cluster. And it's responding, you see. So it's quite a little bit more simpler to operate, and not to create the Helm packages. It can be adventurous. It's a big learning curve, but you have to dig on those kind of tools to deploy in Kubernetes. Let's say for real world production application. So we have it. The pods are there. Okay. Okay. So that's it. We have a container there. Now I want to show you, because you see me fooling around with kubectl command, get blah blah blah. Sometimes it's, and if I want the log, I have to take the name of the pod and so on. So it's okay. You have to know those commands, but you also have to know to be a little bit more efficient. So it's why there's a tool called k8s. K8s is a pretty amazing tool that speed up our operational time with Kubernetes. So I'm gonna type k8s -- my context will be dev. I'm going on my dev cluster, because I have a production cluster too, where I have my company stuff. So on my dev cluster, what I have, okay, we see that here. So I have my 10 replica here of my previous deployment, and I can see all my pod deploy with the Helm chart. So what if I want to delete one? So I can delete one, because what's going on? So automatically the replica set, because it's been set to 4, create another the 4th instance of my container images. Simple as that. If I want to go see the logs, I simply hit L0 and then I see the logs. I can simply go there. If I go Control A, if, for example, my 10 replica, I don't want to go each one by one to see the logs. I simply have to go inside deployments, select my 10 replica deployment, hit L, and I can see the logs of the 10 replica live. And so if something is working, is generating a log, I will see it live. If, by example, at another step for my deployment, I decide to, okay, let's say I want because I'm in dev, I'm in control of what shit I want to deploy there. Okay, I can change the version number of the container image I want to use. Okay, now we are at the version 0.0.1. I want to use the version 0.0.2, but I don't want to play around with those commands and deploy it manually. I will simply change it, hit enter, and then what? It will fail, because my version 0.0.2 doesn't exist. It's not even yet on my Docker hub. It's not there. It will not work. So, but my site, my website that is currently in use, if I refresh the page of my application, it's still working, because of what? I'm going back to see the pods. Okay, I have 3 running container image with version 1, 0.0.1, and I have two other that has been trying to be created with version 0.0.2, but is failing because the image error, image pull backup means the image you're trying to get doesn't exist. So if I look at the describe section, fail to pull image, my hello world, blah blah blah, not found. Fail to resolve reference docker, blah blah blah. So we're gonna fix that. Okay, we're gonna fix that. We're gonna push it to Docker. Clear Docker image. Okay, let's cheat a little bit. Let's say that we create a new version. It's the same but we build the 0.02. It's been built. We have both, and we're gonna push it. Docker push. So my hello world 0.0.2. So we push it. It's push, and here we could see it being resolved in quite few seconds, because it will loop until Kubernetes is able to pull the image. So here 7 times over 2 minutes, 7 times over the last 2 minutes to try to pull the missing image. So we see that. We see here, now it's been resolved. Everything is aligned, everything is up. And we can see that the demo 20 seconds ago, that one 3 minutes ago, it was the one that was failing. And if we look at the image, it's the version 2. If we look at the definition, we have the version 2 there. We can go back to. So it's simple as that. So let's go as a reference. So as a reference, I'm gonna share with you the reference in the YouTube link. Plus I will add also the link to use the k8s tools, which is a Swiss knife. When you work with Kubernetes, you have to use it. It's the better tools I got. It's eased up in my work with that. So thank you for your time. If you have any question about Kubernetes, about those demo, about anything else, don't be shy. Simply reach me out on YouTube or LinkedIn. There's no issue with that. So thank you for your time. Have a nice Christmas holiday and Happy New Year. Bye-bye.